Hello friends, welcome to a series of basic chemical process engineering calculation session 2. Today we were going to check the how to calculate the utility requirement for any particular equipment, that may be reactor, heat exchanger or any one, and its line sizing. For that we have already created a template, whatever the data you have to incorporate it, and based on that we check for the calculation. Okay, first required mass in reactor. We consider this mass based on like 5000 kg per hour. It's 5000 kg. Then specific heat of reactant. For here we assume that specific heat is equivalent to the water. We consider this one. Then we assume that for this is the case for the calculation purpose, so we consider the initial temperature of the reactant is 95 degrees Celsius, and that we have to brought it down to the room temperature. We can say it's at 35 degrees Celsius. Then to calculate heat load based on the mass of reactant, we just have to do the energy balance, because this is the not the case of phase change. So here only latent only sensible heat will take place, and if is is there any latent heat uh, participation in any particular reactor, then you have to add this like m lambda. For here we have to just, for this calculation we just need to consider is mcp delta t. Okay, so based on that, and if is there any phase change from vapor to condensed liquid or liquid to vapor, then we have to add plus m lambda for the calculation. For this case we just need to consider sensible heat. Okay, to calculate the sensible heat we just need to go by one m into this is a cp, specific heat of the reactant, and the delta t, initial minus final temperature of the reactant. Okay, that is the actual heat load which we have to size the utility for this to remove that much amount of heat load. Okay, here we assume 1 hour for this removal. Okay, based on that we are considering the utility as a cooling water. Okay, for cooling water we consider specific heat as per standard 1 kilocalorie per kg Kelvin. Then we assume initial temperature of the cooling water supply is 30, and final temperature is about 35 degrees Celsius, 5 degree of delta. You can consider that 4 degree also. So then we calculate the mass flow rate. As we know, as per the law of thermodynamics, energy neither created nor destroyed. It can be transferred from one form to another. Here Q process is removing, that means it will transfer to the Q utility. So to calculate the mass flow rate, we just need to consider that Q divided by Cp into delta T of utility, so that we can get the flow rate of utility. So that is the kg per hour flow rate required of the utility, 60,000. So we can convert that into meter cube by dividing its density. So required flow rate is of 60 meter cube of cooling water flow rate required to that much amount of heat load in 1 hour. Okay, so based on that we have to size the line size, which I have already taught you how to calculate the line size requirement for any liquid. So here cooling water we considered velocity is 2.5 meter per second. Then we have to just convert to into meter per hour to avoid any confusion during calculation. Okay. So now we have, as you know, to calculate the line size, we need to area of pipe that covers the diameter of pipe. So to calculate diameter of pipe, we have to divide flow rate by velocity into pi by 4. So here we can calculate square root of flow rate divided by velocity into 5 by 4. Okay, so that's the actual line size required in meter. So we can convert that into mm by just multiplying it to the thousand. 1 meter is equal to 1000 mm. So it comes approx 92 mm. So as for standard line sizes available, we can consider round up 100 or 100 NB or 4-inch line size to remove that much amount of heat load. You can calculate by just changing that parameters to different also. If you have considered instead of 5 10,000 kg of mass and that needs to brought down from any temperature, you can also vary the CP as per the process parameters whichever you are going to calculate. So it's we have just changed some parameters like mass and CP of that particular material which is available in a reactor. So for that we required 109 mm line size, so that the one side is higher we can consider with the 150 mm of line size for this calculation, as 125 mm is non-standard and that cannot be used in most of the industries. Hope you all got an idea about how to calculate the utility requirement for the sensible heat removal of any particular reactant. Okay.